හරලා එහෙනම් අද අපි පටන් ගමු වැඩි නේද? Right. So we are to discuss about the electrolysis part. Right. අපි electrolysis part එක තමයි කතා කරන්න තියෙන්නේ මේ session එකේදී. Right. That is the second part under electrochemistry. Right. Electrolysis. හරිනේ? ටක් ගාලා වැඩි කරමුද? Right. Okay. හරි. එහෙනම් start කරමු. Right. Electrolysis. Right. First of all, let's discuss what this means. Electrolysis. Right. Lysis means breaking. Right. So electrolysis means using electricity we are breaking what? Breaking compounds. So using electricity we are supposed to break compounds. That is what we do with the electrolysis. හරිද? electrolysis අපි කරන්නේ electricity use කරලා right compounds break කරන එක. Right. So if you need an example, so let's discuss about some simple electrolysis process you have done in your O levels, right? So you may have done this electrolysis of a copper sulfate solution. Let's say using carbon electrodes. Electrolysis of a copper sulfate solution. Let's say you have copper sulfate aqueous solution. Using carbon electrodes. How this is carried out? Basically, you have to connect two electrodes to a power source, to a battery. This is a positive terminal, this is a negative terminal, right? So if you are to do so, what you will obtain? So copper sulfate aqueous solution was light blue in color. Due to the presence of copper 2 plus ions there, right? What you will ultimately obtain is kind of a colorless solution. If you have to carry out this process, right? Ultimately you will obtain some colorless solution. How that occurs? How that happens? Let's discuss that thing to get some simple idea about the electrolysis processes, right? So what happens here? Right? Basically, this is the power source, no? This is the power source. According to this, right, the electron flow happens. So this is the positive terminal. So towards the positive terminal, electrons will be attracted. Electrons, that negative charges will be attracted towards the positive terminal. And from the negative terminal, electrons will be pumped out. The negative particles will be pumped out by the negative terminal. Right? So that this is going to be the terminal, where the reduction occurs. So towards this terminal, electrons are coming. Electrons are gained by this terminal. So this is the terminal where the reduction occurs. So that is referred to as then the cathode. Cathode is the terminal where the reduction occurs. So this is the terminal where the electrons are going out. Electrons are released. That is referred to as the oxidation. So oxidation occurs at the anode. Anode is the terminal where the oxidation occurs. This is the anode. This is how we are to label the two terminals of an electrolysis process. Right? Then what will happen at the solution here? Right? Towards the negative terminal or the cathode, the cations in solution will get attracted. So this solution contains copper 2 plus ions, SO4 2 minus ions. So the copper 2 plus ions, the cations will get attracted towards the cathode, the negative terminal. The anions of the solution, SO4 2 minus, will get attracted to positive terminal. Opposite charge will get attracted. Right? Not only these two guys, but water is also there. Water is also there. So water from its positive terminal, the hydrogen terminal, it will attract towards the cathode. Water from its negative delta terminal, the oxygen, it will attract to anode. That is how the particles in the solution behaves when the power is supplied to the system. Then what will happen? How the observations are observed. So the main three observations are there in all levels. We had learned main three observations. What are the three main observations we had observed? One thing is color of copper solid solution, the light blue color, decreased. Light blue color intensity decreased, and right, weight of the cathode increased. And what else? From the anode, colorless gas bubbles released. So these are three observations you observed with this process. Let's discuss how they appeared. What are the reasons for those? So light blue color intensity decreased. Why? Why is that? Because these copper ions which came to the copper sulfate, which came to the cathode, get deposited at the cathode. They get deposited at the cathode. So that this reaction occurred. Copper 2 plus aqueous absorbing electrons from the cathode. So electrons are pumped to the cathode. No? You get deposited as copper solid. As the copper sulfate aqueous amount decreased, consumed by this reaction, the light blue color intensity decreased. So this is the one which is light blue color. So as this one consumes, the light blue color intensity decrease. Then the copper will deposit here as copper solid. That is why the weight of the cathode increased. Solid is formed, so weight of the cathode increased. So like this, copper will get deposited. Weight of the cathode will increase. Then what is the reason for this observation at the anode? Basically, the H2O molecules will approach the anode. From there, the oxygen will get oxidized. The -2 charge of oxidation state of oxygen will get oxidized to O2, zero oxygen state, like this. So H2O liquid will get oxidized to O2 gas. right? The balancing is like this. You can balance the half reaction. So these you need two oxygens. So minus 4 is the oxygen state here. The summation 2 of oxygens is 0. So 4 electrons will be released, and to balance 4 H pluses are needed. Right? So that is how this is supposed to be balanced. Right now? So due to this reaction, the oxidation reaction at the anode, you will see the colorless gas bubbles evolve. Right? This is kind of a simple explanation for electrolysis process you have learned in your O levels. So with this thing, right, you can get my idea what I have used to introduce the electrolysis processes. What I have told you is electrolysis is the lysis, the breaking of compounds with the use of electricity. Right? So you will clearly see as you use the electricity, this copper sulfate, that compound has broken. The copper things will get deposited at this cathode, and the sulfate guys are there at the solution. The copper sulfate has been separated. Copper 2 plus at this terminal, if you have to get rid of this terminal like this, the copper 2 plus from solution will not be there. So copper 2 plus is there and sulfate at the solution. Copper 2 plus has been deposited at the throat, and so sulfate things are at the solution. So you have separated the two ions of the compound with the use of electricity. Breaking of compounds with the use of electricity. That is what electrolysis means. This is how the name came to this process. Right? Okay. So in this case as well, you can see the anodes and the cathodes, oxidations and the reductions. Right? And all these things can be seen. And the most specific stuff, most important stuff here we need to learn is actually out of the species which are attracted to the cathode, right, which one will react first? That is what we have to learn here at the A levels. That is the only thing we have learned in A levels. All the other things have been learned in O levels. Out of the species which attracted to the anode, which one will react at the anode? Out of species which came to the cathode, which will react? They see copper 2 plus as well as water, both came towards anode. And our task here to learn what will react first at the cathode and what will react first at the anode. Those are the things we are going to study now. Right? Okay, clear? Right. So before we go into that, those are the major things we are focusing today. Before we go into that, we'll discuss a bit general stuff about this process, right? Which are there in your note. Actually, at the page number 4, your short note, right? These things are there. See, let's go to the note and see what other things appear in there. Right, at the note, page number 4, it says, in electrolysis, a non-spontaneous chemical reaction carried out using electricity. Yes, that is very important to note that. So when it comes to electrolytic cells, when it comes to galvanic cells, or when it comes to electrochemical cells, what we have learned is actually all of those are spontaneous reactions occurring without supplement of energy from the outside. When it comes to electrochemical cells, which we have learned earlier at the last session, all of those electrochemical cell processes involve spontaneous reactions where you no need of supplying energy from the outside. Spontaneous reaction will occur. But when it comes to electrolytic cells or electrolysis processes, these reactions are non-spontaneous. Only if you are supplying energy from the outside, basically in the form of electric energy, you are able to do the reaction. Right? If you come up with the total reaction here, see what is the overall reaction here? The overall reaction. Overall reaction of this electrolytic process is going to be, so if you need to multiply this thing with 2, so the overall reaction is going to be 2 of copper 2 plus H2O right, giving you 2 of copper, right, 4 of H plus, sorry, 4 of, sorry, 2 of 4 of 2 of O2 plus 4 of H plus. Right, this is the overall process. Actually, this thing won't occur no, without supplying energy to a solution containing copper 2 plus ions. This won't occur without supplying energy. This won't occur. So this is referred to as a non-spontaneous process. Non-spontaneous reaction. Delta G for this thing is positive. If you are not supplying the energy from the outside, copper 2 plus ions won't reduce to copper no, while oxidizing the oxygen. You won't see the production of O2 gas from this reaction. This won't occur. Right? Without supplying energy, this won't occur. Right? If you have a copper sulfate solution, if you are not supplying energy from the outside, do you see the copper things will deposit there? Right? No, that is won't happen. It is not happening, right? That happens only if you have to supply energy from the outside. So this reaction is non-spontaneous reaction, not happening, right, spontaneously. But if you are supplying energy from the outside, you are able to do this reaction. Right? Another kind of such reaction is given in your example in your tube. The electroplating. Right? Electroplating of the silver. Electroplating of electrolysis of silver nitrate solution. That is another example. You may have learned that thing also as in your O levels. Right? So in electrolysis, what we are doing is we are supposed to do a non-spontaneous reaction. We are supposed to complete a non-spontaneous reaction by supplying energy from the outside, basically as electrical energy, right? So in these processes, delta G is going to be positive. Delta G is going to be positive. As we know that delta G will relate to the electromotive force of the process from this reaction, right? As these two terms are positive, as delta G is also positive, this E naught cell should be negative here. Should be negative here, as you have negative term here as well. So to give a positive value for delta G, the E naught cell for electrolysis process should be negative. So electrolysis processes are coming up with negative E naught cell values. Non-spontaneous reactions, that means delta G positive values. and E naught cell negative values, right? So for all the electrolytic cell processes, right, the E naught cell values are negative, right? That is also mentioned at your note, right? Other stuff you need to get from this diagram. So, like in electrochemical cell, the oxidation occurs at the anode, reduction occurs at the cathode. That won't change. Red cat won't change. Electron flow direction is always from anode to cathode. From the electrode where you release the electrons towards the electrode, you are gaining the electrons. So, like same as in electrochemical cells, electron flow direction is from anode to cathode. That won't change. But what changes here is actually the signs of the anode and the cathode, the signs. So here your anode is positive. Anode is a positive terminal. Anode is the rod connected to the positive terminal. That is why the anions are get attracted towards the anode, because anions are negatively charged. The anode should be positive. So the cathode is negative here. Cathode is the terminal which is connected to the negative terminal of the battery. So that is why the cations get attracted to the cathode. Cations are positively charged, so that it should attract to the negative terminal. So cathode is negative. So that is the major difference when it comes to electrolytic cell and the electrochemical cell. So in electrochemical cells, the cathode is positive, but in electrolytic cell, the anode is positive. The signs will vary, right? So the three differences with the electrolytic cell and the electrochemical cells processes are the signs of delta G, the opposites, right? The signs of E naught cell and the signs of electrodes. Or sign of electrodes, the sign of delta G, and the sign of E cell. Those are the only three things which will differ, right? At the differ with the two processes, electrochemical cells and the electrolytic cells. All other things are same. Reduction at the cathode, oxidation at the anode, those are same stuff. Electron flow direction is from anode to cathode. That won't change, right? So those are the major stuff. Some basic stuff you should know about the electrolysis, right? So at the page number 5, you can clearly see the differences and the similarities as well. At the page number 4, bottom part, you have the similarities: oxidation at the anode, reduction at the cathode, and electron flow through the external circuit anode to cathode. Those things won't change, and the differences are given. Right, differences are given. The sign of delta G, the sign of E cell, and the signs of terminals. Right now, okay, those are the primary things you should know about the electrolysis process. Okay, let's move towards the most important part of today's lesson. As I have mentioned earlier, the most important part here is the selection of which species will react first at the cathode, and the selection of which species which will react at the anode. That is the major part here. Out of species coming towards cathode, which one will react first? We have to study about that, and then we have to study out of species coming towards anode, which one will react first. Right? Those are two things, major things we have to study now. Let's start with the cathodic process. Let's start with the cathodic process. Which one will react first at the cathode? Right? Okay, let's start. Ready? So, writing half reactions of electrolysis process. That is the topic here. Right? So we are starting with the cathodic reduction reaction. Right? Right? Part B. Right. So how to select? Right? And so first of all, which species will get attracted to the cathode? And second task is how to select the species which will react first. The two tasks will be discussed here. First thing, which species at the solution will approach the cathode, and second thing, which one will react first at the cathode. Right? The point is this. Right? Cathode is your negative terminal. So towards the negative terminal, positive particles will attract. So positive ions, cations towards the cathode, cations will get attracted. Right? So those are species coming towards cathode. Cations towards cathode, cations will attract. Right? Cations. And if you have water, right, positive delta hydrogen from polar water will get attracted to the cathode. Cations and the positive delta hydrogen from the H2 will get attracted from the towards the cathode. So hydrogen is polar molecule, no? So water is with two terminals, negative terminal as well as positive terminal. But negative terminal is on oxygen, positive terminal is between the two hydrogens. From these hydrogens, water molecule will get attracted to the cathode. And if you have any cations, those will also. Right? So now let's just how to select which one will react first. So if you are coming up with some examples, but I'll come with two examples here. right? Let's copy the copper sulfate aqueous solution. This is what we are interested at now, cathode now. So from this solution, you have the copper 2 plus ions and the water there. So copper 2 plus as well as water from positive delta hydrogen will get attached towards the cathode. So if you think of some NaCl aqueous solution, this is your cathode. So towards cathode, the Na plus ions and the water molecules will get attracted towards the cathode. So those are species. The positive things will get attracted to negative terminal, right? Okay, clear? So our next task is to learn which one will react first. Which one will react first? Out of these two guys, which one will get reduced first? Out of these two guys, which one will get reduced first? So at the cathode, we are thinking of reduction. Which one will get reduced first? So the theory there is, right, the species which is more keen to reduce first that means actually the species which is relatively lower at the activity series will react first at the cathode. Right? So we know about the activity series, right? When it comes to activity series, the top guys are more keen to get oxidized active metals. The bottom guys are more keen to get reduced, normally inert metals at the bottom. So according to activity series, you can think of which guys are more keen to get oxidized and which guys are more keen to get reduced. So this is all about reduction at the cathode. So the ones which are at the bottom, relatively at a lower position in the activity series, will participate in the reaction first. As that is all about the reduction at the cathode. Right? So use that idea. Here, when it comes to activity series, right? Copper and the hydrogen are the two atoms approach this thing, and we know copper is relatively lower at the activity compared to hydrogen. So copper is the one which is to reduce first. Right? So Copper will reduce first, the one which is low at the activity is readily. Right? So the reaction happening here is copper 2 plus coming up with some electrons to give you copper solid. That is the reaction at the cathode. Right? So apply the same logic to here. So it comes to activity series. Sodium is above and hydrogen is below. So sodium situated above hydrogen in the activity series, right? When it comes to activity series, below hydrogen, only 5 elements are available: copper, mercury, silver, platinum, gold. Only these 5 are available below hydrogen in the activity series. All other things are above hydrogen in the activity series. Right? So the sodium comes above hydrogen in the activity series, right? That means hydrogen is the one which is relatively lower at the activity series out of sodium and hydrogen. So hydrogen is the one to react here, because bottom guy prefers the reduction while top guy prefers the oxidation. Right? While top guy prefers oxidation, bottom guy prefers the reduction. Right? So the reaction here is the hydrogen is to react here, reduce here. So hydrogen from water. Right? So H2O will get reduced here. So H plus reduced to H2. Right? Plus 2 here. Just a simple redox balancing. 0 here. Right? Minus 2. So 2O4 H minus and some 2 here. Right? Normally, if water is involved in a reduction process at cathode, so we are supposed to balance that thing as a basic medium balancing. If water is involved in a reduction at the cathode in a neutral solution, right? I'll write it here. In neutral solution, NaCl is neutral. If water reacts at cathode, it is going to be basic medium balancing. Basic medium balancing. Right? Remember that. Right? If water reacts at cathode, basic medium balancing, if it's a neutral solution. Right? Keep that in mind. Right? No need to memorize these equations. This is simple redox balancing. This is simple half reaction balancing. So if water is to get reduced, only the hydrogen is the one which approaches the arrow. So hydrogen should be the one to get reduced, right? Water in oxygen carries its lowest oxygen state. Water in oxygen is with its lowest oxygen state -2. It can't get further. It can't further reduced. Only a reduction is possible with hydrogen in water. So +1 oxygen state of hydrogen will get reduced to H2. This is what happens there, right? Because hydrogen is below in that species compared to sodium, right? So out of those species approaching the cathode, the hydrogen should be the one to reduce, right? So keep this in mind. If in a neutral solution, NaCl is a neutral solution, right? If water reacts at the anode, so cathode, it should be a basic medium balancing. That is why we had used some OH minus here, not coming up with H pluses to balance the charge. Right? We had used the OH minus to balance the charge because in a neutral solution, if water reacts, the balancing should be done in basic medium. So the practically they have observed that thing, right? If you have to come up with some, right, some cotton wool with some methyl orange indicator, you will see, right, at the cathode that cotton wool with the methyl orange indicator will show you the basic color, there, right, the orange color, right. So that is why we say it should be balanced in basic medium. So that is not hard to remember, Laman. If water is involved in a reaction at the anode, it is acidic medium balancing. Anode acidic, anode acidic. So the opposite is, if it is water is reacting at the cathode, it is basic. Remember like that. If water is involved in a electrolytic cell process at the anode, it is going to be acidic medium balancing. So that if water is involving at the cathode, it should be a basic medium. Now what is that? Right? That is how you are supposed to remember that thing, right? Okay. So now we know how to select uh, which species will react first, right? Such that now we know which species will approach the cathode and which one will react first at the cathode. The idea is clear. So those things are written there in your note. Just go to the quickly. See, cathodic reduction reaction. So cathode is a negative term here. Cations and H2O from its positive delta hydrogen terminal in electrolyte attract or approach the cathode. The species which is more keen to get reduced. The species which is relatively lower at the activity is react first at the cathode. And two examples are given. These two are given, right? Thing is clear. So better write this thing with the first diagram in your tube, right? Right? In a neutral solution, if water reacts at cathode, basic medium balancing. This is how we are supposed to come up with the cathodic reaction. Right? Right. Just copy the things down if you need any. Right? Ne? Quickly discuss about the anodic reaction. First, we'll discuss about which species will get attracted to the anode, or which species will approach the anode in electrolytic cell process, and then we'll discuss which species will react first at the anode. Right? Okay. Now we are leading to the anodic oxidation reaction. Right. B. Right. Anodic oxidation. reaction. So anode is your positive terminal. So first, which species will get attracted to anode? So anions. Anode is positive terminal. So negative ions, that means anions. Towards anode, the anions will get attracted, right? Anions. What else? When it comes to water, if water is there, water is also with a negative delta terminal. So that will also get attracted to positive terminal, right? So anions and negative delta oxygen from water will get attracted or approached to the anode. Those are the ones which will come towards the anode. Then which one will react first? Which one will react first? That is our next task. So let's come up with some examples here. Right? Let's copy the examples given in your tute, right? So with the copper sulfate aqueous solution, with the use of right copper electrodes as well as platinum electrodes. Right? So I copy the two setups, right? Here is the anode. This is what we are concentrating on. Oxidation should occur there. Right? And this thing, it is a copper solid is used as your anodic terminal. Here a platinum solid is used as anodic terminal. Anyway, our first thing is actually discussing about which species will get approached here. So with this solution, right, you have the SO4 minus ions and water, which carry some negative poles. Sulfate ions approach the anode, as well as water from its negative terminal. Here as well, sulfate ions as well as water from its negative terminal will approach the anode. The thing is clear? Right. Next thing to learn. Which one will react first? Which one will react first at the anode? Lamai, anodic reaction is bit more complex than the cathodic process. Right? Anodic process is bit more complex than the cathodic process. Cathodic thing is very easy. What we need to just look at is the position of the activities. when it comes to cathodic reaction. The one which is lower at the activity will reduce first at the cathode. That is very easy conclusion. But when it comes to anodic process, where kind of oxidation would occur, right? The selection is a bit more complex. Why is that? The thing is, compared to nonmetals, in your solution, oxygen, sulfur, those are nonmetals. Compared to nonmetals in your solution, metals are more keen to get oxidized. At the anode, we are expecting kind of oxidation. So if we are with a metal, right, which can get oxidized, definitely it will react, it will participate as the anodic process, not anyone from the solution. That means basically when it comes to these anodic terminals, right, most of the situations we are coming with the metals no, as electrodes, as terminals. We have to use conducting species. So normally, usually we are coming up with metals. The only other option is carbon solid graphite. Metals or carbon solid graphite should be used as the two terminals of a electrolysis process. So there, if you had used any metal, other than the platinum or gold, definitely that metal is the thing to get oxidized, not anyone from the solution. So metals are very keen to get oxidized, but not the platinum and gold. Platinum and gold are the two bottom metals at active series, which will never get oxidized. At the bottom of the active series, you find the platinum and gold. Platinum, which is known as the white gold. Platinum and gold, very expensive stuff. So those things will never get oxidized, which are at the bottom of the battery series. Other than those two, all the other metals, we can see some oxidations. Even in silver, you obtain silver as silver nitrate, silver chloride. There silver appears as silver plus ion. So silver is also capable of coming up as ions. So other than platinum or gold, if any other metal is used as your anode, that is the one which is going to oxidize, and not anyone from the solution. Right? So here you have the copper. So copper is the one to get oxidized, not anyone from the solution. Copper is the one to get oxidized, not anyone from solution. That is the first point. Right? So such anodes are referred to as active anodes. If you had used any metal other than platinum or gold as your anode, those are referred to as active anodes. Then that is the one to get oxidized. No need of concerning anything at the solution. Right? So that is the first point. If if an active anode, what are active anodes? Anode is a metal other than platinum or gold is used, then anode itself get oxidized. No need of looking at species at solution, right? Anode itself will get oxidized actually and dissolves. Right here, copper is an active anode. Copper is an active anode. So copper solid get oxidized like this. And get dissolved. Anode will get oxidized and dissolves. So no chance for the species at the solution. So species at the solution are actually non-metals, right? Compared to non-metals, the metals are very keen to get oxidized. Release electrons. That's the point there. Right? Okay. The second thing, if an inert anode, or one can say passive anode, if an inert anode or passive anode is used, passive anodes are what? When platinum, gold or carbon solid graphite is used, like this, if an active passive anode, if an passive anode is used, then this guy is not going to get oxidized. We have to look at the species at the solution, right? Anode metal won't oxidize, and metal won't oxidize. We have to look at the species at the solution, right? We have to look at the species at the solution. They are the considerations. First consideration. So here this is not going to involve, right? As it's a passive anode. So out of the species at the solution, right? Polyatomic oxygen ions never oxidize. What are these polyatomic oxygen ions? Sulfates, nitrates, carbonates, phosphates, sulfites, nitrites, Oxoanions, oxygen containing anions, polyatomic, not the OH minus. Polyatomic means normally more than 2. Polyterm is normally used in chemistry for more than 2. If you are with 2 atoms, it is diatomic. Diatomic molecules. Diatomic species. Polyterm is normally used for more than 2 is there. When 2 is there, diatomic, biterms are used. Bidentate ligands. Remember, when 2 lone pairs are, they are to be related. But more than 2, those are polydentate. Polyterm is used when you are having more than 2. So polyatomic oxoanions. That means oxygen containing anions with more than 2 atoms. Sulfates, nitrates, phosphates, sulfides, carbonates, nitrites, like that. Chromates, dichromates, manganites. Those will never get oxidized. Those will never get oxidized. So that no chance for sulfate. No chance for sulfate. Then out of the species remaining there. Out of the species remaining there from the rest of the species. Right? From the rest of the species. Right? You have to know some order to follow. Right? Let's follow the following order. To get oxidized. What is the order? First comes the turn of negative ions, the OH minuses as well as the Cl minuses. Those are the most keen guys to get oxidized, first of all. Then comes the Br minus, then the I minus. If you don't have any negative ion, then a chance for the water. Then a chance for the water. Right now? Or? So it's already win. Thing is clear? Right? So that here the water will get oxidized. Right? So water get oxidized. So let's write the reaction there. Water, the oxidation could occur from the oxygen side. So that towards O2, it will get oxidized. Towards O2. 2 of oxygens just balancing as normal. 2 of oxygens. So 2 needs that. Oxygen state balancing. Minus 2 into 2 is minus 4. This is 0. So you need some 4 electrons here. The charge balancing. So if the water is used at the anode in a neutral solution, it is going to be an acidic medium balancing. Acidic medium balancing. So 4 of H plus. So 4 hydrogens are there. Things are balanced. So write that like that. Write that thing as well. If H2O is oxidized, at anode in a neutral solution, right? Acidic medium balancing. Right? No? Okay. So that is how we are supposed to come up with the equations. Again, I'll give you a little summary. What is summary of selecting which species reacting first? Out of species which approach the anode, to decide which will react first, first we have to concern about the anode, whether it is a active anode or not. If it is an active anode, that means if the anode is made out of a metal other than the platinum or gold, then no need of looking at the chemicals at the solution. The anodic metal itself get oxidized. If you are dealing with the active anode there as the anodic metal is the one to get oxidized and dissolved. No chance for the species at the solution. Right? That is what happens here. As copper is a kind of an active anode, it oxidizes at the anode and dissolves. No chance for the species at the solution. But if your anode is kind of a passive anode or inert anode, that means if your anode is made out of carbon solid graphite, platinum or gold, if your anode is made out of carbon solid graphite, platinum or gold, then the anodic stuff is not going to dissolve or not going to oxidize. Then we have to consider the species coming towards the anode to write the reaction. That is what happens here. Platinum is a kind of active anode, so it is not reacting there. We have to consider species as the solution to come up with the anodic reaction. Out of the species as the solution, we first get rid of polyatomic oxyanions. Polyatomic oxyanions are not used in these oxidations. So actually the point is, it is hard to approach the anode when it comes to polyatomic oxyanions. Because polyatomic oxyanions are very heavy. Those are very heavy. So that ionic mobility is very less. Heavy stuff. So it is hard to move. So it is hard to approach the anode if you are a polyatomic oxyanion. Before you approach the anode, the simple water molecules, which are very small water molecules, which is nearby the anode, will participate in the oxidation process before the polyatomic oxyanions approach that anode. That is why we say polyatomic oxyanions won't react at the anode. Right? So first we get rid of polyatomic oxyanions. Then we will consider this order to select which species will react first at the anode. First consider the negative ions other than the polyatomic oxyanions. Then if you are not with any negative ion, then water has the chance. Right? Okay, they are OH minus, Cl minus, Br minus, I minus. So here what happens, here what matters is actually for this oxidation, the charge density line. If you are very small, you can approach the anode pretty easily compared to large guys. When you are small, it is very easy to approach the anode. Two things are there: because you are small, you can approach easily. As you are lighter. The second thing is your charge density is high. That means easily get attracted to the opposite charge as charge density is high with your small size. That is how this order comes, right? So here we don't have any other negative ion other than the polyatomic oxygen, so water has a chance here. So water get oxidized, producing O2 gas. So in water, oxygen is the only species which can get oxidized, right? So because hydrogen is with its highest oxygen state +1, so it can't get oxidized. So in water, oxygen is with its -2 oxygen state, which is the lowest oxygen state of oxygen, so it can get oxidized, right? This is what happens here. So keep that in mind. If water is involving in an anodic reaction in a neutral solution, definitely that should be balanced in an acidic medium. That is why we had used to balance the charge the H pluses. Right now, that is clear. Right. So that's it. So just copy the stuff if you need. So all the things appear in there in your note. If you need to copy anything, you can copy, right? So after that, we'll do some warm up things appearing at the page number 7. Right now, man. Balloon the exercise කරන්න ඊළඟ page එකේ තියෙන. හරි. At the page number 7. Some exercises are there for you to do. Right. So what are the 4 exercises there? So you are supposed to write the reactions at the cathode and the anode for these electrolytic cell processes. First do the first 2 things. This means first draw the setup number. Draw the setup clearly. Right. So this is with platinum solid as your electrodes. The second setup. So I have mentioned here the electrode, right? Electrode material. So here carbon graphite is used. Right. So try to come up with the 2 reactions here. at cathode as well as at anode. Just try. Right. So first of all, you need to select which species will react at the cathode and which species will react at the anode, right? Okay, let's do that working. So out of this, so you have the Na plus ions and the Cl minus ions here. So Na plus will approach the negative terminal, the cations will approach the cathode, and anions will approach the anode. It's like this, no? So electrons are pumped to here. So this is reduction. So cathode. So electrons are right attracted to positive terminal, that is oxidation. Anode. Towards anode, the anions will approach. Towards cathode, the cations will approach. As well as the water from its positive terminal, hydrogen here. Here as well, water will approach from its negative terminal. Right. Let's discuss which one will react. Out of the two species approaching the cathode, you know, hydrogen is relatively lower than the sodium in the activity series. Hydrogen is relatively lower than sodium in the activity series. So it will reduce first at the cathode. Right? So the reduction is coming from H2O liquid. So if H2O liquid is to reduce, hydrogen, the plus one oxygen state will reduce to H2. No other option. Oxygen can't get reduced here. Oxygen is at its lowest oxygen state. It can't get reduced, so hydrogen is the one to reduce, right? So let's balance this off. Normal balancing. Plus 2, 0. To balance oxygen states, you need some 2 electrons at this side. Balance oxygen state. Right? The charge balancing. So what is involved at the cathode? What is involved at the cathode? In a neutral solution. In a neutral solution, what is involved at the cathode? That means it's a basic medium balancing. If it is involved at the anode, acidic medium. At the cathode, basic medium. So OH minus should be used to balance the charge. So minus 2 at this side. This side, no, that means 2 of OH minus. Finally, balancing the hydrogens, you have 2, 4 hydrogens, so that means another 2 is needed. That is how you are supposed to copy the cathodic reaction. Let's come up with the anodic reaction. When it comes to anode, first you need to consider the metal here. When it comes to cathode, no need of thinking of the metal, right? Because metals never get reduced. Metals never get reduced. So no need of thinking of the metal. But when it comes to anode, you have to think of the metal. Think of the anodic material, right? Okay. As oxidations could occur with the metals. So even though this is a metal, this is a inert metal. Platinum, gold, carbon, solid, graphite never participate in the anodic reaction. Inert metal. Then we have to consider the stuff appearing at the solution. So you have Cl minus. Before the water, negative ions are involved, right? Negative ions other than the polyatomic oxygen ions, right? So this is not a polyatomic oxygen ion, Cl minus. It will involve here. So Cl minus is the one to get oxidized here. Cl minus will oxidize to Cl2. So balancing, 2 chlorines, atomic balancing, 2 should be there. Now oxygen state balancing is -2, -1 into. So some is 0. So 2 units of difference. So -2 is needed. That means 2 electrons are needed. Right now? That is balanced now. So that is the anodic reaction. Right now? Right. Let's write this off. First of all, write the species nearby those corresponding terminals. See how to write this stuff. So towards this positive terminal, the electrons are attracted. So from this terminal, electrons are released. That is oxidation. So this is the anode. So electrons are pumped out from the battery from here. So to this terminal, electrons are gained. From this terminal, electrons are gained. There's a reduction. Reduction happens at the cathode, red cat. Towards the cathode, cations are attracted. Towards the cathode, cations are attracted. Towards the anode, anions are attracted. Towards the anode, anions are attracted. Water is also there. Water is also there. Water from its positive terminal approach the cathode, the negative terminal. Water from its negative terminal approach the positive terminal. Right? Okay. Let's select which one will react first as the cathode as well as at the anode. First, the cathodic reaction. So out of the two species, hydrogen and silver situated below hydrogen in the active series. So silver is the one which is more keen to get reduced at the cathode. So silver is the one to participate here. So silver plus will get reduced to silver. So 1 electron is needed here to balance the oxygen states. Then the anodic reaction. First, we need to consider the anode, whether it's an active anode or a passive anode. Yes, this one is a passive anode, not a metal, right? Other than the platinum and gold, it's not a metal, carbon solid graphite, passive anode. So then we have to select from the solution, species from the solution. So polyatomic oxygen ions are not participating in the reactions at the anode. Then time to H2O here. No other anions are there, so H2O will get oxidized here. If H2O get oxidized, it will form the O2. Oxygen is the one to get oxidized here. Now we have to balance this stuff. Atomic balancing, two oxygens are needed. Oxygen state balancing, so you have -2 into 2 is -4, 0. So to balance oxygen state, you need -4 here, so that you need 4 electrons. Then the charge balancing, minus 4 is there, here 0. So again a neutral solution, and what is involved at the anode? What is involved at the anode? If what is involving at the anode, you have to do some acidic medium balancing. So charge should be balanced with the use of H plus there. With the use of H plus, you have to balance the charge. So 4 of H plus should be this. So that is your anodic reaction. Right now, let's complete this after. Right. Shape diagonal. Right. Let's do the other two. Right. Number 3. Using cutting electrodes, we're supposed to utilize some H2SO4 aqueous solution. Right. And the number 4, using magnesium electrodes, we are supposed to utilize magnesium chloride aqueous solution. Right. Let's try to come up with two equations of the cathode and anode. First, draw the picture, right? Without a picture, you can't comment. You can't think of what will happen there. Let's try to do the third and fourth ones. Right, let's try to do this one. So first of all, you have to write the species coming towards the anode and the cathode. See, just mark the things properly. Towards this positive terminal, the electrons will attract. From this negative terminal, electrons will be pumped out. So electrons are coming towards this terminal. So that is means it's a reduction. Electrons are gained by this terminal, reduction. That means this is the cathode. Electrons are going out from this terminal. So that means a kind of oxidation. So this is the anode. Right? Towards the cathode, the cations are coming. So what are the cations? The two ions here are H pluses and SO4 minus ions. The cations H plus ions are coming towards the cathode. The anions SO4 minus ions are coming towards the anode. Not only that, water is also there as a solution. So water from its positive terminal coming towards the negative terminal. Water from its negative terminal, the oxygen terminal, coming towards the positive terminal. Right? Those are the positionings of chemical species nearby the two electrodes. Right? Let's copy the equations now. First, the cathodic equation. So both are hydrogens, right? At the cathode, you are expecting sign of reduction. H plus is coming, H2O is coming. So basically, H plus with a greater positive nature will attract easily towards the cathode, and it is smaller as well. So H plus is the one to get reduced here. H plus AQ will get reduced to H2 gas. So balancing, 2 of H pluses are needed. So 2 electrons are needed. This one, right? So what are the platinum? Platinum things are used, no? So platinum rod. Platinum rod is referred to as a inert anode. Platinum, gold, carbon, solid, inert anodes. No use there for the reaction. Then we are thinking of the species appearing in the solution. SO4 minus is a polyatomic oxygenate. No use. The remaining stuff is the H2O. So H2O is the one to get oxidized at the anode. So H2O will get oxidized to O2. H2O will get oxidized to O2. Don't forget to write the physical state, right? You won't get marks if you haven't written the physical state, right? So let's complete this off. 2 oxygen atoms are there. 2 should be written. Then oxygen state balancing. One oxygen carrying -2. Such 2 are there. -4. This is 0. So to balance the oxygen state, -4 is needed for this side. That means 4 electrons. And charge balancing. So this is acidic medium. It's not a neutral medium, this is acidic medium. So definitely charge balancing should be done with the use of H pluses. With the use of H pluses. So 4 of H plus. Right? Okay. So that is the oxidation half reaction at the anode. Let's do for this one as well. So first of all, mark the anode, cathode and stuff. Electrons are coming towards here, positive terminal. Electrons are going out from the negative terminal. So this is where the oxidation occurs. It's the anode. This is where the reduction occurs. It's the cathode. So magnesium solid electrodes are used. And out of the species as a solution, the cations coming towards the cathode, anions, the elements will come towards the anode. And water is also there. So water from its positive terminal, the hydrogen coming towards the negative terminal, and water from its negative terminal, oxygen coming towards the positive terminal. That's how the chemical species are to be positioned nearby the two terminals, right? Okay, let's come up with the two reactions there. First, the cathodic reaction. Cathodic reaction. Out of the species coming towards the cathode, the one which is very keen to get reduced will reduce first. That is the one which is relatively lower at the active series. Relatively lower at the active series. So when it comes to active series, hydrogen is relatively lower at the active series than the magnesium. So H2O will reduce first. But H2O will reduce first. H2O will reduce to H2 gas. Right? Let's balance this off. +2, 0. So to balance oxygen states, 2 electrons are needed. That is how the oxygen states are balanced. Then charge balancing, -2. So you need some -2 at this side no charge. So 2 units of charge is needed. This is a neutral solution. We can take it as neutral solution, right? Not a strongly basic or strongly acidic. So water at the cathode, that means basic medium balancing. So 2O4 minus this side to balance the charge. Right? To balance the hydrogens. 4 hydrogens are there. We need some 2 here. That is the reduction reaction at the cathode. Let's do the oxidation. So when considering the anode, first thing to consider is whether the anode is active or inert. The thing is, actually this is active, kind of active anode. Anode is made out of a metal other than platinum or gold. Is active anode. So no need of thinking of the species of the solution. Anode itself gets oxidized and dissolves. So magnesium solid will oxidize to magnesium 2 plus and dissolves. That is the oxidation process at the anode. So balancing the oxygen states. So you need some 2 electrons here. And charge is also balanced there. It's active anode. Right now? So this is how we are supposed to write the two equations with the when you are supposed to utilize some magnesium chloride solution with use of magnesium electrodes. Right now? Let's complete this off. හරි ළමයි. හරි. ඔබට question එකක් කරමුද? හරි. අන්තිමට බහයි questions වල ප්‍රශ්න තමයි මේ electrolytic cells ලොකුවට use වෙලා නැහැ. හරි. අපිට එහෙම ක්වෙස්චන් එකක් හම්බ වෙන්නේ ඉතින් ඔයාගේ අන්තිම ක්වෙස්චන් තමයි. Let's do the 2024 question. Right? Question number 5 at the page number 20. Page number 20, question number 5. This is 2024 A-level question. Question number 7. 2024 question number 7 paper එකේ. බලන්න. අපි tute එකේ නම් question number 5 in your tute 2024 question. Let's do that stuff. In your A-level paper 2024 question number 7. There are electrolytic cell processes involved. We can identify that thing as power supply is used. දැන් ළමයි වගේ මේ power supply එකක් use කරලා දිනවා අනිවාර්යෙන් electrolysis එක. හරි? Process is done with use of external energy supply, right? So බලන්න question එක කරා. 24 question එක. paper question number 7 එක. But just try. I'll give you 5 minutes, right, to try the question. Then I'll do the working, right? හරි නේද? අපි try එකක් දෙමුද? Okay, let's try the question. Right. Magnesium metal can be extracted by the electrolysis of molten magnetic chloride using inert electrodes. Example platinum graphite කියලා දිනනවා. හරි. So a sample simple setup for this is shown in the diagram, right? Some setup is shown, right? Let's go to the setup quickly. Setup එක කරලා දිනනවා. platinum කියලා මාක් කරලා දින මෙතන. graphite මාක් කරලා දින. molten MgCl2 කියලා මාක් කරලා දිනවා. electrolytic cell කියලා මාක් කරලා දිනනවා. අපරාධي මාක් කරලා දිනවා. එහෙම දෙන්න ඕනෙත් නෑ නේද? power source එකක් තියෙනවා අපි තේරුම් ගන්න ඕනේ මේ. power supply එකක් තියෙනවා. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 150 151 152 153 154 155 156 157 158 1 හරි ඊට පස්සේ මැග්නීසියම් ලික්විඩ් එකක් මාක් කරලා දින පොඩියට බින්දු බින්දු වගේ කියලා. අනිත් පැත්තෙන් ක්ලෝරින් ගෑස් එකක් ඉවුල් වෙන බවත් තමයි මාක් කරලා තියෙන්නේ. එහෙනම් මාක් එකක් තියෙනවා. මොකක්ද හරියට තියෙනවා. හරි. හරි වැඩිය. හරි. So see, identify the anode and the cathode. Write the half reactions taking place at the each electrode. Cathode එක මොකද්ද? anode එක මොකද්ද? Right? Number 1. Right? What is the cathode? What is the anode? You see what happens here, lamai? So if you reach the magnesium from here, definitely magnesium 2 plus should approach that terminal. Without approaching the magnesium 2 plus towards that terminal, you can't release the magnesium liquid there. So to release Cl2 gas from here, Cl minus should approach this terminal. As Cl minus gas approach that terminal, the Cl2 release from that terminal. So Cl minus is kind of a cathode, Cl minus is kind of an anion. So anions are approach to anode. So this should be the anode. Very easy. To release the Cl minus from here, so to release the Cl2 from here, Cl minus should approach this terminal. As Cl minus is kind of an anion, anions are attracted to anodes. This is the positive terminal. What about this? To release magnesium liquid from here, magnesium 2 plus ions should approach this terminal. As magnesium 2 plus is kind of a cation, positive ion, no cation, so cations are approached towards cathode. So this is the cathode. This is a negative terminal. That is why the positive ions are approached there. Right now? So that electrons are pumped towards here. Reduction would occur here. Electrons are going out from here to the positive terminal. The electrons are going out. Oxidation occurs here. Right now? Let's answer the question. Identify anode and cathode. Right, so anode is what? Anode is your graphite electrode. And your cathode is your platinum electrode. And they are asking you to write the half reactions taking place. Half reactions, anodic half reactions. This right here. Anodic half reaction. See, that is Cl minus releasing Cl2. So Cl minus Aq get oxidized to Cl2 gas. So balancing, the atomic balancing first. 2 of chlorines, 2 needed. Then the oxygen state balancing, minus 1 into 2 is minus 2. So is 0. So 2 electrons are needed to balance oxygen state. Charge is also balanced. That is the anodic reaction. What about the cathodic reaction? So Mg2 plus ions approach the cathode. It will reduce to Mg. Solid. So the oxygen state balancing, 2 electrons are needed here. Right? That is how we are supposed to identify the anode and cathode and write the corresponding equations. Right now? Problem 2. Write the overall cell reaction. Overall cell reaction. How to write the overall reaction? So overall reaction is the summation of or combination of the two half reactions. You can consider this one as 1, this one as 2. This complete summation of or combination of these two. There we are supposed to get rid of these electrons, get rid of these electrons by adding the two. So two electrons, just adding the two will cancel off these two electrons at the left and right. So overall reaction can be taken by adding the 1 to the 2. So that will give you some magnesium 2 plus, aqueous plus 2 of Cl minus aqueous, gives you Mg solid plus, I'll write here. So 22 plus is some 2 of Cl minus aqueous. No, the aqueous liquid, right? Sorry, for liquid. It's molten, no? It's molten, no? Liquid. Giving you Mg solid plus Cl2 gas. Right now? Okay. Problem 3. Study direction of electron flow through the external circuit as the cell propagates. Electron flow direction? Yes, we had marked that thing. Always from anode to cathode. Always from the electrode which releases electrons towards the electrode which accepts the electrons, right? Anode to cathode. That means graphite electrode to right, platinum electrode. Right, problem number 4. Explain the following. Molten magnesium chloride liquid is used instead of magnesium chloride solid in this extraction process. Instead of magnesium chloride solid, right? If magnesium chloride solid is used, the anions are immobile. Anions are not mobile, immobile. Anions can't move. The ions can't move. Without the ion movement through the solution, through the liquid, you can't think of a conductivity. Conductivity won't occur. So you are unable to observe this, right? In magnesium chloride solid, ions are immobile. Cannot move. So conductivity is not there. To carry out the electrolysis. Right now? Okay. That is Roman number 4, part 1. Part 2. A solution of magnesium chloride cannot be used. Why so? In magnesium chloride solution or magnesium chloride aqueous, H2O molecules are available. So that what will happen? The H2O will also approach this cathode, and H2O should be the one, is going to be the one which will reduce at the cathode, because hydrogen appearing lower than the magnesium that is here, so hydrogen in the H2O will get reduced. so that you are unable to extract the magnesium, right, as magnesium 2 plus is not going to react at the cathode. That is the idea. So not the magnesium 2 plus, but H2O will reduce at the cathode. So Mg solid, so Mg liquid cannot be obtained, extracted. Right now, that is why molten magnesium chloride, that means magnesium chloride without water, is needed here. Right? Aqueous can't be there. Right. Problem 5, some calculation there. Problem 5, some calculation there. Let's do the calculation. If 5.37 ampere current is passed through this cell for 1 hour, so power supply, right, given you 5.37 amperes for 1 hour. So IT terms are there. So these will leads you to the charge Q equals IT. So charge is provided. And what they are asking is calculate the volume of Cl2. Volume of Cl2. Right? So what we can do? So as charge is given, Q is equal to IT. With use of these two data, you can copy the charge. As charge is given, with the use of Q equals NF, you can copy the number of moles of electrons. From this, you can copy the Q. As Q equals NF, by dividing this Q value from the 96,500, you can copy the number of moles of electrons. That moles of electrons will be related to the moles of chlorine gas. Half amount of chlorine gas will produce, right? Compared to the number of electron moles, half amount will produce as chlorine gas. So if you know the moles of chlorine gas, you can use the P equals nRT as the pressure and temperature is given. As the pressure and temperature are given, as you know the moles of the chlorine gas, you can copy the volume with use of P equals nRT. It's a 4-variable equation. If you know about 3 variables, you can copy the missing piece, the volume in this case. Right now? So we'll do that approach. We'll go through that approach and copy the answer there. Right now? Okay. So I'll erase these things. Right? This is clear. So we'll copy the calculation there. Right? This is Roman number 5. Right? Find your charge pass through circuit. So Q is equal to IT. What is I? I is this. T is 1 hour. You have to copy the SI units, right? Then only you will copy the answer in coulombs. The SI unit. 1 hour means 60 minutes, 60 seconds. Right? 60 seconds is 1 minute. Such 60 minutes are needed for the 1 hour. Let's copy this number. 5.37, no? Sorry, 5.37. 5.37. 37, sorry. So we multiply with 16 to 60. 9,300. Right? The answer will be like this amount of coulombs. So amount of moles of electrons is equal to that amount of coulombs divided by the Faraday's constant. We give you the moles of electrons. The 0.2 moles. Right? So now we can relate the electrons to the number of moles of Cl2. From anodic reaction, right? Cl2 to electrons are with 1 to 2 ratio. So chlorine moles are equal to half the amount of electron moles. That means 0.1 moles. So now we can use the Beker's linearity to come up with the volume of Cl2. So pressure is given as 1 atm. We have to substitute with the SI units. Volume, that is what we need. Number of moles is 0.1. Right, the R 8.314 joules per Kelvin per mole. Temperature is given as 300 Kelvin. So we can simplify the stuff. 10 to the power 5 is there, V is there, 10 to the power minus 1 here. This thing can be taken as 100 over 12. This 300. So this becomes 4. Right? So you have 10 to the power minus 1, 10 to the power 3 here, 10 to the power 4, and minus 1 is 10 to the power 3. So those things will cancel off with this, as 10 to the power 2 remain in there. So volume is actually 1/4 to the power minus 2. Right? You're taking it as 10, this 10 to the power minus 3. So this is going to be 2.5, no? 2.5. 2.5, right? Decimeter, meter cubes, no? Meter cubes. The answer comes with this unit. Right? So they are asking us the value in decimeter cubes. So it is equal to 2.5 decimeter cubes. Right? When applying Beker's linearity, as long as your substitution is done with these units, the answer comes with these units, right? So V is coming up with the cubic meters, so that can be converted to decimeter cubes. Right? Okay. Right? That is how we are supposed to solve the question. Right? This completes up. These are steps we had used. Okay, just complete the question now. That is 2024 A question. Pretty easy stuff, huh? Simple stuff. හරි ළමයි. එහෙනම් අපි අදට මෙතනින් නවතිමු. right මම මේ බෝඩ් එක ලීව් කරන්න මේ විදිහට. ඔයාලා කොපි කරගෙන ඊට පස්සේ ඔයගොල්ලෝ ට ලීව් වෙන්න පුළුවන්. right නේ? හරි එහෙනම් good night day. So next week we don't have the class, right? So after that, at the next week we'll meet then. Goodbye then. Good night.